Hello and welcome to the week 3 of our course. In this week, we're going to talk about some assembly language and basic operation in it. And we're going to see like how the memory works. So let's start with some introduction. We have seen the Newman architecture and basically has defined five components for each computer. We have the input, output, memory unit, control unit, and arithmetic and logic unit. And this one is referred to as LAU also. So this is basically existing in many computers, and it's kind of like a very broad category. So if you look at your computers today, they all have like kind of a CPU. You have like an Intel processor most probably, and that is basically going into this category. You have some memory, some hard drive, HDD or SSD, and those are basically is your storage or your memory. You have your IO devices, you have monitor, keyboard, mouse, and so on. So this the components are like you can see in many different computers, but the way they appear are very different, and that is basically depending on the use of that computers. So depending on the function and the application of some system, the designer of that system is basically um, designing specific devices or components to be efficient for that system. So for example, here we have personal computers, and for that, you have some criteria. So some of them, maybe if it's a laptop, you want it to be portable, so it cannot be so heavy, right? So that's one constraint that you have. So depending on that, or based on that constraint, you basically using different components or different forms of that components to meet that criteria. Um, we have here three main or three broad categories of computer, kind of like a bird's eye view. If you want to separate all the computers into these three categories, you have the personal computers, of course, that you're using every day. We have the servers, and we have the embedded computers. So this one you're familiar with. Usually it's a single user or very few users use that. It's supposed to be low cost, and usually you have third-party software on it. What about the servers though? So servers, you first of all, you don't access them directly. So you don't actually go to your server and like plug a monitor to it and work on it, right? So usually you kind of like SSH to that, or you have basically access it through the network. So you remotely connect to that. And their main like their purpose is to have a high workload. Many of them, they're like multi-tenanted, so that means they have so many different um, people or customers or clients using that server at the same time. So on the lower end, you see that they're used for like file storage or small businesses, or you have your like a simple web server that could be a VM that is like lives in some server or data center. And the higher end, of course, they have like supercomputers, and that are kind of like grids of many processors and a lot of memory that is connected together. So examples of this, you are probably familiar with AWS or Azure or Google Cloud, and that is like something that you can easily access to. But also companies, they have their own data center sometimes, or I think like SFSU, they have their own servers inside the campus, right? So that's the another category of the computers. And the idea here is that the use case for this is different, right? So you are not supposed to access it in person. They are not portable, and they are targeted to have a very high performance. So that's a kind of a different um, function or different requirements for that. And because of that, that if you look at the designs, like you see, they could be bulky, but also sometimes they're on racks. So they're the way that they're designed is that maybe they're easily if something goes off in one unit, you can easily like replace that and so on. And of course, you have the embedded computers. So this is actually might be surprising, but it's actually the largest category of computers. So embedded computers are usually designed to do a single task, or like a very specific task. And usually the software for these are designed specifically for that. So they do have basically all these components that we talked about here in some form. So they have some processing unit, they have some memory unit, even though it might be very, very small. So for example, your digital camera, it has a processor on it, or the I don't know, the remote, or in your car. So there are so many different examples of that, or like sensors in the home, the thermostat, like all these different if it's digital. So that's the category of embedded computer, and that goes for um, different design criteria, which is like it should be very low on energy, and probably you want it to be very small. So that kind of uh, constraint resulted in a different design. So here we see actually we're gonna take like a closer look at basically same components that we talked about. So we have the CPU, which is the processor, main memory, of course, which is like we're gonna talk about this a lot more, but basically it's kind of like a temporary storage or volatile. That means that basically if the power goes off, you lose the content here. Um, and you have some IO devices that like input and output. So you have some screens or keyboard and so on. You have the system bus that is like connecting all these, but most importantly is the CPU here. So that is basically like the brain of the computer, right? It's doing all the calculations. So within the CPU itself, and I think we have an image. Yeah, so this is like the zoom in, like a close-up view of a CPU. And here you see like there's a multi-core, is the Intel i7, so it's multi-core. So this is like 8 cores I see here, and it has like different components here. So it has a cache, it has a memory controller, and so on. So each of these cores here that you see, it's basically one like this here. So all the components that are here are actually repeated in each of these cores. So that's kind of like the very basic one core that we are seeing here. Um, so we have like control unit. So what are those? Like, let's look at them. Control unit is basically kind of like orchestrating all the things that are happening in the CPU. So for example, if you are reading from the memory, writing from the memory, so like certain signals has to be sent to different devices. And control unit is kind of like managing that. You have the LAU that we saw it here as arithmetic logic unit. So that's LAU. And that basically is doing all the calculation. Any arithmetic operation that you have, like you're adding two numbers, it's gonna be done here. And if you have any logical operations also, so you have an and or like a logical and or logical or, that's gonna be also happening here. You have some registers and program counter. So there is like kind of like a very super fast memory that is on the CPU itself. So you can read from this and write to these, most of them. And basically it is accessible by the CPU, and that's different than the main memory. So there is very tiny amount, and they're called registers, and we're gonna see much more during this course about these. And program counter is just like a special register that is basically telling this processor which line of code it's being executed.